All right, so we are going to look at sine and cosine graphs, which we've had a little look at. And so, well, first of all, we're going to look at a basic sine graph here. Okay, so y equals sine x. And we've noticed that if you, when we go round, if we notice when we went round the unit circle, we went up to, so say we had, we went up to pi on 2, we saw that sine was 1, so we'll see the graph grow up. And then when we came down back to pi, sine was 0, because remember 0 was at 180. And then when we got to 3 pi on 2, it was -1. And then when we're back at 2 pi, it came back to 0. So how long it takes to do one cycle, so meaning one up and down, that's called the period. So on a basic sine graph, the period is 2 pi, okay? And the amplitude, which the amp is how far high it goes from 0. So from 0 up, it goes to 1. So this one, and that's taken from this number here. So we assume there's a 1 there. So this one's amplitude is 1. It's going to peak up at 1 and drop down to -1. All right, now what we need to do when we're graphing is another thing we want to really look at is working out the intervals. So I've sort of drawn them here because if you look, we pretty much have 4 sections that are of interest, like points of interest. So if we start with 0, but then we hit the peak, the maximum, then we're back to 0, then we get to the lowest, the minimum, and then we go back. So you can see it's sort of divided into 4 sections, like the quadrants. So when we're graphing it, it's very, it makes it a lot easier and better if you work out what we call them the intervals. So if you mark on the graph on the axes, the intervals. So for the interval, the way you find the interval, you do the period divide by 4. So you can see in this example, we would have had the periods 2 pi and we divide by 4. So it ends up being pi on 2. So you can see every half pi we're going up by, and there's the interval. All right. So if we draw them, that makes it easy. We know we have to draw up to that point and down. So let's have a go at doing some. Okay, so we'll just repeat over. So when we have a basic sine graph, so sine graph, we're going to see this basic up-down shape, okay? And the period is 2 pi and the amp is 1. So we've looked at all that and it goes down. When we have the, sorry, it's written twice there, I don't know why. When we have cosine, cosine's basic shape is here and it goes down and comes back up. So we start at the maximum and we go down. Now, you can see it still takes 2 pi to do one whole pattern of it. And the highest value it goes up to is 1 in a basic one. And that's because there's a little 1 in front of that. Okay, now the periods are still the same. If you have a look here, because we would say, sorry, the interval. So the interval on a cosine still the same. You do the period divide by 4. So for this example, 2 pi divided by 4 equals pi on 2. So you can see it's going up. These points of interest, like they're all at pi on 2. All right, so have a little look. We talked about this the other day. So this number is going to give the amplitude. This number is going to affect the periods because you do 2 pi divided by whatever that number is. This number here will move the graph up and down. And later next week, we're going to see that this number moves the graph left or right. Okay? All right. So let's just get through. So here, just summarizing, you might want to just write down, because I believe that bit's not in your notes, and I think it's important to put the intervals, and it makes, when we do transformations, so when we're moving them, it will make it a lot easier if you've got the interval. So remember, the intervals are the period divided by 4. All right, so let's go practice. So we get this graph and they're saying let's graph 3 sine of 2 theta. Okay, so what we'll write down the amplitude. So what's the amplitude for this one? Sorry, Jack, your face is there, so I'm going to ask you, Jack. No, he's gone. Anyone?
Sorry, miss, what was the question?
What's the amplitude for this graph here?
3.
Yeah, good, 3. So we've got 3, so it's going to peak up to 3 and down to 3. So what you might want to do when we're sketching it, what I would say is once you've got your amplitudes, you know it's not going to go out, so just get your pencil and maybe draw your line, a nice like sort of faint line along those. So I've gone 3 and -3. It's just so I know I'm going to go up to there and down to that. So I've just done that in there. Okay, now this number in here, so is going to help me find the period. So remember the period, so just go back to pen. The period is 2 pi divided by n, which is this number in front of the angle, or they sometimes represent angle with x. So in this case, it's 2 pi divided by 2, so it's pi. So essentially what's going to happen, just really quickly, if you have up on your x-axis, the angle gets up to pi, because this is a sine graph, it's going to get through it it's going to do one cycle in pi time. Okay, so if you had, so for there. Now it's important, we're going to find, I said it's much easier if we find the intervals as well. So the intervals is the period divided by 4. So in my case here, it was pi, it was the period divided by 4. So we're going to see those points happen at every quarter of a pi. Okay, so, but the only thing is this is a radian value. Okay, this is a radian value for the angle. And over here, they're telling us, this is telling us the domain. So along our x-axis, they've given it in, the domain's in degree. Okay, so we might want to change our interval, or even our period into degrees. So what's pi in terms of degrees? It would be, how many degrees is pi? Think of the circle.
180.
Yeah,
180.
Yeah, good, 180. And if you have a quarter of pi, how many degrees would that be? Pi on 4 would be 45 degrees. Would you agree with that? Half of pi, 90, yeah. Okay, so these intervals are going to happen, all those points of interest are going to happen after every 45 degrees. So what I know is it's 1, 2, 3, 4. They're where all those, that's where all the points of interest are going to happen. Now, they want us to go all the way up to 360. So we're going to see this cycle a lot. Yeah, so we just keep, but let's just do the first one to show, the first part to show you. So we know we've got the amplitude. We now know it's going to take pi to get through it, or 180, and we're going to start off thing. And here's our point. So with a sine graph, it starts at 0, then it peaks up to the top amplitude, which is 3, then it comes back to 0, then it comes down to -3, and back to 180. So if you look, I get this, I can see that it's doing this little pattern there like that. Okay, now they want it to keep going. We'd have to keep cycling through. So if you were thinking about your intervals, so we can see it's happening every pi 45 degrees. So you can keep, maybe they've obviously been nice and they've drawn that up on our axes there. So then I'll just keep going. It goes up, comes down, down to here, and down to there. So there is my graph. Now, just to be like really super careful in year 12, and because they've said they've included saying in between those numbers, but not including it because it doesn't have the equal to bit on it. So we probably should have our dots at the start and at the end. We're going to have an open dot. We're going to have an open dot to indicate that, okay? So we're just a little bit exaggerated there, like that, okay, boys? So we'll just have that open because we know we're not going to include those because the formula says no. All right, so that's the first one. So let's go and try another one. All right, so we are first going to look at these and we're going to find the amplitude. Now, it doesn't matter that there's a negative for the amp. It means we're going to go up to 2. So the amplitude's 2. Let's find out what the period is. So the period will be 2 pi divided by the number in front of the angle. They've decided to represent angle with t. Doesn't matter. It just means this axis along here is t. Okay, and this one we call the function, whatever. Okay, so we're going to say 2 pi on 3. That's how long it's going to take to do one cycle. But remember, as I said, best to find the intervals so that we know where all those little points are. Now, the interval is the period divided by 4. So if you do 2 pi over 3 divided by 4, it'll end up being 2 pi on 12, which can simplify down to pi on 6. Okay, so it's pi on 6. Okay, once we've got like the intervals, sometimes it's easier to change also our period to the same denominator. So because I want to make it 6, so I might say that's the same as saying 4 pi on 6, just so I can see them as they climb, but it doesn't matter. So if you go through, let's do our intervals. So it's every pi on 6. So if this is pi on a third down here, then half of a third is a sixth. So that's the first one, that's pi on 6. Then it goes to, add another one, it'd be a pi on 3. So 1, 2, 3, 4. So there's my intervals. So this graph is probably going to be really, on this page, going to be super narrow. But anyway, let's go. So we're going to go up to the amplitude. I like to you can just draw it in pencil. I just reckon it looks a bit, so you can be neat when you're sketching. So draw 2 lines up on your amplitude, just nice and faint. Now, because this graph is a negative. So remember, we go the reverse way around the negative graph. So we'd be going the reverse way around this unit circle. So if it's cosine, normally cosine would start up at the max, but if it's a negative, it's the opposite. So we're going to go, we'll start down at, we'll start down at the bottom. What's it doing? Oh, I don't know. Anyway, all right, so we're going to start just down at the bottom here. Okay, and every interval we're going to go up. So the cosine, it starts at the bottom, then it goes to the first, goes to 0 in the first bit, then it peaks up to the top because we're doing negative, it's going the other way around, then it comes back to the 0, and then after a full period it's back to the start. So you can see, oh god, this is bad, it goes like that. Okay, and then if you divided up all your intervals and you keep going, they want us to go up to 2 pi. So 2 pi in terms of thirds would equal 6 pi on 3, wouldn't it? Yeah? So, or they've written 2 pi anyway. So we'll go all the way up there. This graph's going to get chocker. So we're just going to have to keep putting you put the points. Okay, well, sorry. It's very messy, isn't it? Sorry. Hopefully you're better at control. This is my best, oops, I've gone the wrong way. My best effort on the iPad. Ugh. Like that, sorry. So that's the cosine graph. Once again, I should probably have, because they're not saying equal to there, let's just keep them open, those dots down there, okay? The first and last one. All right. Okay, so is that all right? So if it's the negative, remember that it's the opposite. You go down the opposite way. So if you have a negative sine graph, you're going to go down, up like that first, okay? All right, we still have to go back to negative pi, which is over here. So we saw our intervals were pi on 6. So if this is negative pi on a third, halfway through there is pi on 6. So you can see you got 1, 2, 3, 4. So it would revert back and do one cycle. So we would pop in those dots. So I'll go up, down, sorry. Now we've got to keep going to pi. So keep going like that. So we probably get, where do we get to? We get back up to here and then back up to the top. So we get like that. Oh God, like that. Yeah. So does that make sense? So the period is just one of them. So just like here. So between 0 and 2 pi, we see one peak, one bit of the pattern, the one pattern of cos. Because remember, cos normally looks like that, yeah? But we've got a negative, so we're going upside down. Yeah? All right, so let's do this one. So here is the domain. I should really check that. So it means they want me to go from negative a half, which we've got on our axes out here. We've gone out, and they want me to go up to 2. So we're covering it there. And they're calling it t, not x, so we'll just call that negative t back there. And then this is just, we'll just call it the function. Okay. All right, so let's go look at our certain things. So if we look, we want to find the amplitude, which is this number here. Sorry, I don't know why it's done, it's written it twice when I've dragged it into this app. Okay, so the amplitude is 2. So you can see if we got our, we can see we want to go up to 2 and we want to just go down to 2. Oops, draw the line. Okay, so that's where our graph's going to go. Let's look at our period. So the period equals 2 pi divided by this, which is pi. So this one ends up being 2. So it's just going to be a number. So we're going to see one full cycle done by 2. And if we think about the interval, remember the interval equals the period divided by 4. So it's going to be a half. So we're going to see these points at every half. So when you go half, then the next one will happen on the 1, next one will happen on 1.5, and then we get to 2. And then if we go backwards as well, so if we're at 0, we'll see our first thing happen at a half. All right, so this is a sine graph and it's positive. So we know the first thing we do is we go up and then we come back down to 0. Then we go, oh God, sorry. I should try to do curve and then come back up like that. Now they want me to continue. So this would have gone down, curve down and stop down there at negative a half. All right, so there's our graph. So it just helps to see where, if you put the intervals, you know you've got to go up to there, down to there, and that makes it easier. Now, these had square brackets, so I can have a solid dot at each end, and that's fine. All right.